Okay, right. So in this week 6, we're gonna learn about section view and dimension. If you look at here, it's actually not much materials for today, so we can maybe finish it in maybe in an hour or so. And also, as similar with previously, I also uploaded some videos on the links, video links from YouTube. And if you still need to have more understanding, you can also check in the YouTube some video about section view. Right. So if you remember last week, we talked about the projection theories. Okay. So we start drawing some specimen, and then we want to check the how to draw the projection theory using third angle projection, first angle projection, okay, like front, top, and also from right hand side. So here we're gonna learn about a section view. So section view is actually uh, just like want to. Okay, I need to close my video then. Okay, because the okay. Okay, so here the section view reveal the hidden feature. Okay, so the section view will reveal the hidden feature. So for example, if we want to look at the, if we have this object and then we look this one as the plane, okay, so uh, from the normal multi-view drawing, we know that this is from the front side, yeah, from this side. We know that it's only the thick lines or the straight lines is only like this block, okay? So if you see it from the sides, only this block, okay? But we know that inside it, okay, there is also a block and there is a bore and a hole around here, and also something like this, and this also there is a hole. Okay, so because the dash line, if we have too much dash line, it doesn't really give us some more information about it. Okay, so instead we put the plane on uh, the front like this. We can cut them into a section view like this. Okay, so we cut them in the middle, yeah, so like this we cut them in the middle. So this is going to be the section view with two arrows in here. Okay, so this is from the front side. Okay, oops. So maybe I can start to draw. So we know that this is the front side, okay, and then this is the top side. Okay, this one also from the top side. So from the top side there, we cut just really on the center points of the whole, this one, yeah, we have the center point, and then we cut it. This is not denote with the plane, okay, this one here, yeah, the axis, and then just put it with the phantom line, sorry, yeah, this like straight line and then small line and then straight line again is called phantom line, yeah, if you remember. This is to cut them for a section view. Okay, so then after that we cut them, and then we can with this imaginary plane we can cut it like this. Okay, so here we can see some more feature. So this line over here tells you about the inside the material, yeah, because it's actually it's not a hole, but it is just material, and then we cut it. Okay, and here we can see the hole, and then with some axis over here, okay, and then over here also we can see the hole and the bore. Okay, so because of that, then it is gonna be much easier compared to this one. Okay, so here we can and then here we have some more lines, and then and also more straight lines and more thick lines to for us to see. Okay, So again, so the section view will reveal the hidden feature. Okay, and this also another typical cutting planes. Okay, so we have this is the line of sight. Okay, and then they have a little bit of cut over here, and then there is a hole over there, and there's also a cut over here. So if we draw it from this line of sight, all the hole and all the the line over here is just gonna be dash lines. Okay, so what can we do is we cut them to have a imaginary cutting plane. Okay, so the imaginary cutting planes used to create section view that are passed through the object to reveal interior feature. Okay, so if we have some equipment, and then we can want to see the interior feature, so we can use the cutting plane. Okay, so this one, so usually the hidden lines are omitted from a section view. Here, yeah, the hidden line. Give me 1 second there. So, okay. So here we can have an imaginary cutting line, cutting plane over here. So this is the front side. So if this is the front side, yeah, the normal orthogonal lines, and this would be from the top side, look like this. Okay, and then we cut it through this plane, the imaginary cutting plane, and then we can see the section view. So in the section view, it is more we can see more about this, yeah. So here is actually the surface, permukaan, yeah. So it is not with those lines, tidak terarsir. Okay, so you can see here that this one is all the surface, and then the one that have the material on, and then you need to make it this, the inclined lines like this. Okay, so another one, the optional use of hidden lines. It can be shown in section view, usually to eliminate the need for another view. Here you cut it in that one here. So this is the optional use of hidden lines to get to know that there is something cut over here. Okay, so because again, you know that if you cut through the axis of this hole like this, yeah, the axis of this hole, you cut into here, you know that there is this area over here. Okay, to make it like that. Okay, so I think this is actually the basics of section view, yeah, and the dimension. And then here you also we can use the object. Okay, so for example, it is like a bore with a higher, larger diameter, and then we have another one, the bore with the smaller diameter. So it would be like this. So let's say consider we cut just in the middle like this. Okay, and then when we cut it, it becomes like this one. This is the correct representation. Why? Because we know that we have this line, yeah. This actually will be represented by this line. Okay, so the change of plane behind the cutting plane, so the plane, this one, it would be represented as a line. So we have to make this line. Okay, don't write it like this. So this is not the incorrect representation, and this is actually just the normal multi-view from the front, yeah, if we don't consider the section view. All right, so let's have a look the next one. Okay, so and then this one is the placement of the cutting plane lines, where in another example, if we have the cutting plane is placed in the view where the cutting planes appear on the edge. Okay, so again here we have a block, and around here is there is some room, and then there's a hole, and the inside there is something over here. So here we will have the the plane, the section view. Okay, and in order to see which one this is the correct cutting plane, okay, because then we have we have this one here over here. Okay, so the arrow is going to be wrong in the direction over here, so the arrow should be show the line side of necessary for section view. Okay, so before we continue, so I think it's a good idea if we together watch the videos from some of the additional video that I explained to you. So maybe we can see, wait, so let me prepare some video first. Okay. Okay, so here there are 3 additional videos that I try to see. Otherwise, there are a lot of videos also from the Indian lecturers, right? If you want to see, that's also fine. There are 3 videos. This is a very, very old one again, but again, it has some very, very basic fundamentals of it. So you can have a look at this one. And this one, let's have a look about sectional view in technical drawings. So maybe I can make it bigger. Okay, yes, oops, so let's have a look there.
In this lesson, we're going to be taking a look at a special type of technical drawing view called a section view. For some objects, standard orthographic and pictorial views can't show all of the details needed to manufacture the part. Additional views might be needed to show special features. One of these special drawing views is called a section view. Section views slice away part of the object to show us interior details that can't be seen from the outside. They can be used in orthographic drawings or pictorials. Usually, the hidden internal features of an object would appear as hidden lines in orthographic views, but it would be against the rules of dimensioning to dimension to those hidden lines. By removing the surface of the object with a section view, we can get a direct look at those various features and edges, and we can dimension to them accurately. A section view shows us an object as if it were cut in half. The location of the cut is indicated by a cutting plane line on another drawing view. Cutting plane lines show us where the object was cut to create the section view. They are thick, bold lines with a 2-dash pattern repeated every so often. Arrowheads on the ends of a cutting plane line point in the direction that the object is viewed in the section view. Letters on the cutting plane line match letters on the section view it creates, which helps prevent mixing up views when multiple section views are created in the same drawing. These lines take precedence over all other lines on the page, so if they happen to fall in the same spot as an object line, the cutting plane line is what is seen and the object line falls behind. There are several different types of section views that we'll be looking at in this lesson, including full sections, half sections, offset sections, broken out sections, and revolved sections. We'll also see how section views can be used for assemblies as well as individual parts. In a full section, the cutting plane line passes all the way through the object. The portion of the object behind the arrowheads is removed, and the cut object is seen in the direction of the arrowheads. Let's see an example. Imagine that the part is cut at the cutting plane line, and the portion opposite from the arrowheads is removed. If we look at the object in the direction of the arrowheads, we would see this section view. The hatched areas use lines called section lines to indicate where solid material was cut to create the view. The areas without section lines were hollow and do not show section lines. Normal object lines representing edges still appear, but hidden lines representing invisible edges do not. A half section is typically used on symmetrical parts where it is beneficial to show internal and external details in a single drawing view. The cutting plane line cuts halfway through the part, cutting away only 1/4 of the object. A single arrowhead is used to indicate the direction of view. The section view appears much like a right-side orthographic view, except that the lower quarter of the object is removed to show the internal details. This allows for all of the part's dimensions to be shown with only 2 drawing views instead of a front, a right, and a full section view. Offset sections show multiple interior features in a single section view, even if the features don't line up with each other on the object. The cutting plane line changes direction as it travels through the part, slicing through the center of key features that would each need their own section view otherwise. The resulting section view isn't made from one straight cut, but from a strategic offset path created by the cutting plane line. This eliminates the need for several cutting plane lines and section views for a single part. Section lines indicate where the solid material of an object has been cut to reveal a section view. These are thin, angled, parallel lines. They should not be drawn parallel or perpendicular to any of the object edges that they meet, and the same angle and spacing should be used throughout a piece of material, even when the cut areas are disconnected by non-cut areas. Sometimes it's useful to show section view details without drawing an entirely new view. Broken out sections allow us to do this by peeling back a portion of the object's surface to reveal details underneath. Instead of a cutting plane line in another view, the cut area is defined by a jagged, short break line. Broken out sections allow dimensions to be placed on the surface of an object as well as to hidden features further back. Another way to show sectional details without creating a totally separate drawing view is to use a revolved section. In this example, a long object with a noteworthy cross-sectional shape is sliced on a plane along its length. The object is revolved in this location to show its cross-sectional details in line with the drawing view instead of as a separate view elsewhere on the page. Section views can be very useful for revealing the details of an assembly where some parts are hidden inside others. When section views are used this way, it is important to use different patterns and angles of section lines on different parts to clearly distinguish between them. Section views are a common tool used in architectural drawings to reveal interior spaces or elaborate construction details. In this application, there is a wide variety of patterns used to represent different building materials, so a reader might need to rely on a legend on the drawing to distinguish between concrete, dirt, wood, fiberglass insulation, stone, and other materials sliced in the section view. Now that you know the basics, try to create some section views of your own. Look back at the lesson anytime if you need some help. You can also check out my video on creating section views Inventor, which will walk you through the process in CAD.
Need to cut it.
Thanks for watching.
Okay, so that is one video about section view. I think it is quite explaining yet about that one there. And one more, let's see a very old video. Oops. Let me here let me upload it again. Wait, where is it? I think this is quite similar, but with some real objects. So even it is a very old video from McGraw-Hill. McGraw-Hill is the name of publishing groups, but it is really useful because we have the real object in that one. Okay, just enjoy and then have a look.
Suppose you wanted to make a drawing to describe this movable jaw from a drill press vise. You cannot see what the inside looks like, but if you could cut away part of it, you could see the inside quite clearly. Or in a similar case, take this hub, which also has important details on the inside. You need to show these details in the hole, but they cannot be seen clearly from the top or front. An ordinary front view would show the inside features by hidden lines, but this is not a good way to represent them because you want to show them more clearly. You can make your drawing easier to read by a method called sectioning. Imagine that you can pass a cutting plane through the object, and that the part of the object in front of the plane can be removed. Now you can see all the inside details clearly, and you can make a drawing of the hub as usual in orthographic projection. This view is called a section or sectional view. Those parts through which the cutting plane passed, you will indicate with fine lines at an angle, evenly spaced, called section lining. Do not section line parts beyond the cutting plane. Show the top view in full, but add a special line called a cutting plane line to show where this imaginary cutting plane passed. Arrows to show the direction in which you look at the section, and reference letters to relate the cutting plane line to the sectional view. Because the cutting plane passes clear across the object, this particular view is called a full section. However, you can use the imaginary cutting plane to make different kinds of sections when they are needed. For example, when you have a different kind of object, such as this, a continuous cutting plane may not reveal all the details you want to show. If you made a section on just one plane, here for instance, it would not show both holes. Therefore, imagine a cutting plane which is offset, so that it will go through all the details you want to see in the sectional view. Now both holes will show clearly in the drawing. Project the view as usual, but do not indicate the offset on the sectional view because it is imaginary. On the top view, show by the cutting plane line how the cutting plane is offset. A view like this is also called a full section. Sometimes when you have a symmetrical object, you may want to show both the outside and the inside in the same view. In such a case, you can imagine that the cutting plane goes only halfway through the object to the center, and think of only 1/4 of the object as being cut away. This method creates a half section, showing both outside and inside details.
Okay. Okay, looks like this one is a little bit lagging, so I think we can just stop this one. So looks like this video is a little bit lagging, so I think we can just stop here. But actually, this is the real object, for example, and then you cut it to get the section lines. All right. So now let's just continue with our PPT again. Okay. So here, at least from the video, you can have some more description. Okay, and then let's have a look again about this placement of the section view. Okay, so so let's see on the page 8 over here, we can see that the standard cutting plane is similar with the phantom line, which is should be terminated with arrows. Should be a long lines and then a short dash over here, and long line and short dash over here. If you try it using SolidWorks, it's gonna be automatically, you don't need to remember it, so it's just gonna be automatically on the softwares. Okay. However, for the mid exam, if you need to ask or there is a question about this, you should also be able to answer this one. Okay. So here, so let's have a look over here. So how about the horizontal section view? Okay, so suppose this is the front view. Okay, so the front view around here. Okay, and then this is the top view. So we know that there is a hole like that. Okay, like a block, and then there's a hollow inside here, and there's just a little bit of hole in here. So we want to know the features of the one that the critical one with the one with the holes. Okay, so instead we have a the vertical section. We can also be able to cut the horizontal section. Okay, so the imaginary cutting plane is actually in a horizontal section. So horizontal section view is one where the cutting plane is on the edge of the front view and the top view is section. So here, which is on the horizontal section, this is the horizontal view, and then this is the point of view. Okay, so we're gonna see in this area. Okay, so if we cut it through here, we know that this is all the visible lines. Okay, the visible lines, and also this is the hole. Okay, the hole from here, because we cut it, so we can see the whole dimension, the whole in here. And this one here, all the the inclined lines tells you about the material. Okay, the block that we cut with invisible plane, imaginary cutting plane, I mean, yeah. Okay, and here we have also another plane over here, so we can see it from that one. Okay, the next one is the multiple section view. The multiple section view is the where we have one plane, and then we cut it into two section view. The section view A, which is this is the line of sights, and this is the section AA. So this is the plane that we cut through the horizontally like that. So this is from the top sides. If we see it as a section view, and this one if we want to know the one that we see from the vertical one. Okay, so this is section BB. Okay, I have a question. Why we have to put the arrow into the to the right, to my right? Why don't we have the arrow into that one, to the other sides? Anyone would like to ask my questions? Why we have to put the arrow to that sides? Why I don't write my arrow to that one? Because if we draw to that side, we only can draw this one. Okay, and here is just a block. Okay, but the more important view is actually this one. We want to emphasize that there are a hole in it. Okay, so rather than we see into that line, that point of line of sight, then this gonna be the section. Okay, so by cutting the imaginary line and then with this direction of sights, we can reveal that here is actually a surface. Okay, because so this one, okay, so this one is actually about this surface. Okay, and we can emphasize there is a hole over here, so this is a hole, and while here the material cutting is this one. Okay, that's also similar with the upper one. Okay, when we cut it, why it's not in that direction? Okay, so why we don't write in that direction? Because the more the important feature is actually about this block. Okay, so this block is more important. Okay, so because this is more important, so then we can see we have to see in this line of sight. Okay, all right. So this one is the ANSI standard section line for various material. So all the for example, if we use iron, it would be looks like this. If you're steel, like this one, and then this is a bronze, and so on. So later on, if we have a section view for different materials, we can see, we can revert the legend to see what is the material of the alloys and so on. Okay, so this is, for example, for the sand, this is for water and liquid, this is the grain or wood, this is for rocks and marbles and so on. Okay, so actually why it looks like this, because usually most equipment came from cast iron or malleable iron. But if we're using steel, if you're using steel, stainless steel, for example, then we have to use this one. Bronze, brass, and copper, it can be in heat transfer equipment, it can be in valve, it can be in some other things, but it's not as common as iron. Right? Okay, so this is also should be one of your practice at home when you draw using manually or in your hands, so for hands-on skill. So when you draw them, so we have to have a 45 degree equal raising, okay, that one there, and then should be equal and correct spacing. Okay, this one is incorrect, so mine was incorrect. So I think it's good if you can just using the ruler, yeah, for this one. So this is incorrect actually, yeah, the one that I write here, because the line work fails at the end of the boundary of the area, so I can't be like more than lines. This one also incorrect because the line work is too closely. This one is incorrect because the line work is too widely spaced. This one is incorrect because the line is not parallel, so it's not consistent with the direction. So you can see that there are some with quite not parallel yet, so it's not consistent. And this one also, even though it is 45 degrees Celsius, 45 degree, and but it's incorrect because the line work intensity is inconsistent. Okay, because the lines, the thickness of the lines, which actually will determine the drawing. Okay, and this one here, this is the preferred one. If we have this type of like this, for example, like this sample, it's not, it should be avoid, so we have to be preferred like this. So avoid placing section lines parallel or perpendicular to visible lines. So if in case you have an object with 45 degree of the visible lines, and then it is the section lines are parallel, so you have to change the section lines into around 30 degree. Okay, so this one, so it's not 40 degrees, so but maybe around 30 degree, so it doesn't parallel with this one, because I think this one is around 45 degree, right? And then how about the thin parts? Okay, let's say this is a screw, and this is like a small piece of okay, of those hole, another piece of hole, and then this is a gasket. So this is called gasket, and this is a screw. Okay, so this is how you draw it. So the first one, it would be in this direction, and the other one should be in the other direction. Okay, so don't write them in the similar direction, like parallel to this one, but in different direction, just to ensure that you have different specimen, you have different object. Okay. So this is also another example. If we have section lining the adjacent part, here this is the line that adjacent part, so we have the adjacent part in assembly section or section line at different angle, so the individual part can be easily identified. Okay, maybe I know I saw this picture quite a lot, yeah, in some equipments that I see in unit operation books, yeah, but actually no, I know that actually this is actually the rules of technical drawing. Okay, so this is the adjacent part, and then this is the other one. So you can see here that they doesn't have a similar parallel lines but different, so just to make sure that it has in different angle and the individual part can be easily identified. Okay, and then here you can see you have like a dash line a little bit, yeah, garis yang terputus. This is also shows that the material of this part would be a different material symbol compared to the upper one. Okay, so let's have a look about the full section view. So the full section view is the one that we see in the video when we have a plane and then we full by just cutting a plane fully through the object. Okay, and then where to cut it, we have to cut it on a very important symbols. For example, in this case we have a hole here with some this is the axis, and on the center line as well on the axis we also have the hole. Okay, so here, okay, so this is a standard multi-view. If we don't consider section view, from the front it's just like a block, okay, but we know inside it there is a hole in this way and there is a hole in that way. Okay, and from the top side we see that there is a bore over here with this center line, and the center line would be similar with the hole over here. Okay, so the what we need to do, we have to make a section. Okay, for the section, and the section what we see maybe for this case is quite similar, yeah, this side and that side, so you can have a plane, it's really up to you on the top or on the bottom. This one is usually in that direction. Okay, so just don't make lines maybe over here, or don't make line over there, so that's not the right way to do. But you need to do is make the cutting plane in the center point. Okay, so by this one you fully see that you have axis here. Okay, so the here, and you have visible lines because you see now on the full section view it's like you cut them. Okay, and this is the material, the material, and this again there is a hole. So the better you have the visible lines there, is their drawing is going to be more clearly compared to this one. Okay, rather I know that looks good if we see that, okay, look, there would be a hole in it and a hole in it, but it is much be more clearer if we see in the full section view. Okay, and the second one is called half section. Half section view is created by passing a cutting plane halfway through the object. Especially like in the video, we know that half section, if we know that the part is actually mirrored with each other. Okay, so we can see more better from the half section view. So we can cut using like this, yeah, there. So here we can see that this is going to be the half section. Okay, so this is a half section. We know over here because we see the surface, yeah. We can, so if we see from this point, we from here to here is actually these sides. Okay, from the top side we know. We can't see anything, but from here we know that so this, if we cut this plane, it's actually we know the surface of this. Yeah, this one is actually the surface of this one, and then we have seen that some material around here up to here. Yeah, so there is a material over here, and also there is a hole. Okay, and then the hole is over here. Okay, so but we know is actually this section would be mirrored with that one, okay, from over here, because we know that in the top view it is mirrored between this side and that side. All right, I think after this all about more about how to write the section here, yeah. So another one, offset section, like in the video before. So if we have some important object and those important object is not in one lines with that one there. Okay. So here what we can do is we can just make the lines on the important feature. So this one from here, the important feature is the center line there, okay? And then you can cut it up to here, and this is the important feature is this line, and the center point, and then you go that one again, and the important feature is that line. Plane, okay? So when you cut it and then try to imagine that you cut that with this plane, okay? And then you see it from the front side, okay? So this is called the offset section view. So it tells you about the feature that the dimension of this hole, and also the dimension of this bore over here, and also the dimension of that one. If you know, because here is actually we have a center point, so there are axes here, so we know this is a little bit of like ellipse like that, okay? And then when we cut it, we don't show the cutting point over here, okay? Because it's only the material. Because it's only material, then we have to just continue line over here, okay? Okay, and then the next one, the last one, is the line section. In the line section, we can cut it the plane. For example, this one is quite mirrored, but in divided by 3. Yeah, so there is 1, 2, 3 part, 1, 2, 3 hole as well. So rather than we cut it like that, and we don't see this essential feature, we can cut it like 120 degree from this one. From this one and that one, okay? And then we can see the preferred here, so we can see the maximum or the feature, this hole in here, okay? And we can see the outer hole as well in here, okay? So this one is preferred compared to true projection. So rather than we cut it like a vertical, like half, because we don't have the true projection, so this one would be preferred. Okay, so that is about the section. So again, there are full section view, and then there is a half section view, okay, and then there is an offset section, and then after that there's a line section, okay. So I hope you can remember, you can understand. So when you need to try to have it in the exam, yeah, the exam is only in the next 2 weeks, I think, or maybe in the next 3 weeks, I don't know, because next week is next week is holiday, right? So then so I think it's very good for you just to remember them, and then also, so if you need to describe those sections, you be able to describe the section. Okay, the next one is about dimensioning drawing. Okay, so there are number elements in dimension drawing. So how we can draw the dimension. In I didn't use SolidWorks for my day-to-day activities, but I saw my husband working about SolidWorks for his day-to-day activities, for his projects, and I saw that in SolidWorks it is easy to click this and that and this and that. Yeah, just using the click, you can it would be automatically tell you about the dimension. Okay, or yeah, or there's another I think there's a lot of freeware software as well, similar to SolidWorks or AutoCAD or something. Try to draw like that. Okay, so the first one, this is a dimension. So this is the dimension. So this is how you write the dimension. And then the second one, the number 2, is this. It's called the basic dimension. Like this, you can also write it like this, with some arrows. And then this is the dimension lines. Then dimension lines very important if you have a limit of size or you have a tolerance. So for example, this is the maximum for your tolerance and this is the minimum for your tolerance. And this is the extension line, just to make sure that you measure this length from this side to that side. Okay, from for example, from this point to that point, like parallel, so you have an extension line. Okay, and then let's see. So this is, for example, the front view, and since this is from the side view, from the side view, you see that you can write it like to here. This is actually radius symbol, or 0.75. Okay, or you can use this one with the radius up to here, which is tells you about the diameter symbol, and this is the leader line. Okay, you can also write rather than limit of size, you can just write the nominal, and then you write the plus and minus dimensioning, yeah, like we learned before. Okay, and or we can write like all format is plus 0.05 unless otherwise noted. It can be written like this one as well, or you can write the reference dimension. Okay, so just be aware of all those elements in dimension drawing. Okay, so here.
No.
Okay. Right. So this is about the size and location dimension are used to describe parts for manufacture. For example, this is the size. Okay, or if you have some size here, you can write that this is going to be the location, and this tells you about the diameter of from the center point to this one, or it can be all the size, that one there. Okay, so we need to describe all the parts for the manufacturer. So because again, the technical drawing is actually used for to easy to make it the technician make the part easier. Okay, so here let's say we have to know with some origin. So we have to get the datum plane. For example, we have this plane, so this is going to be the datum surface for horizontal dimension, and this is the datum surface for vertical dimension. So if we have a different hole like this, we can draw all the dimension with reference with the baseline. Okay, for this case is the vertical dimension y, and also for horizontal dimension x. Okay, so a part dimension using coordinate dimension with a baseline or a datum surface as a starting point. Okay, and this one is the minimum dimension line in spacing. This all is actually tells you about the I think this is just the length here of them, and then this one, this is just a very what should I say, the rules, yeah, like for example, how when you draw the arrow, it should be only 2 millimeters below the lines. Okay, so it's really it looks trivial, but it's not. Okay, and then you also need to see those visible gaps. So don't draw the extended line like up to there. Okay, so but you have to leave some visible gap in here. Okay, so you have to leave some visible gap around here. okay? And this one here also, the length of this one when we do the dimensioning also around 6 millimeters in drawing and 10 millimeters in drawing, up to there, okay? So the minimum dimension line spacing. Okay, so here also we don't need to draw okay, so do not use object lines as extension lines in the dimension. So here, rather than we draw it inside the object, okay, so we don't need to draw the lines inside the object, but it's actually use the extension line, okay? So this one, this one, this one, and this one is the extension line. Okay, so rather than, so don't write it like this inside the object, but on write it on the extension lines. Okay, like this. And also we can avoid over dimensioning. If you have you done some dimension of A and B, of course you know what is this dimension, which is A minus B, so we don't need to add some more dimension here. Okay, so it's either you have 2 dimension here or A and B, so you just omitted the other one. Okay, and then this is the dimension for the mass description view. This one is the prevert, yeah, from the outer one, rather than here, because sometimes it is going to be overcrowded and then you can't see the dimension clearly. Okay, and then this one is the staggered dimension text. We can click it from outside. But again, all of this rule is actually all the basics rule or all the rule of thumb. But when you, if you have access to SolidWorks and you can have play around with SolidWorks with some object, I think you can click this and click that, and this would be actually automatically displayed on your SolidWorks. Okay, so here also this is if you have this part, you need again to have an extension line again here, for example. So you can have a break extension. Maybe you may see this in some drawings, but actually is one of the rules that you have to have a break line over here, just to make sure that this actually tells you about the extension. Okay, and then this one is the unidirectional and align method. So this is the current standard. What is this difference? So that means when we draw, it should be in all horizontal, yeah, when we write them. Okay, so previously it is quite aligned with this one here, so it becomes vertical because the line is vertical, and this is horizontal because the line is horizontal. But here we make it in the similar direction. So because we read it horizontally, so then the numbers also horizontally. Okay, and then we can also use a symbol again to use a repetitive features. For example, so this is using repetitive features. For example, here we have 4 holes, and it's actually we use symbol x, yeah, multiply. So 4 multiplies with the diameter 0.375. Right, and then when you draw when we want to interpret this one here, the line should be if you extended the arrow and the line, it should be extended into the center point. Okay, so don't just randomly, you know, draw the this one here. For example, you randomly write the diameter, and then when you extend the line, it actually becomes that one. So you have to pass the center point. All right, and this is the symbol for drilling operations. the symbol to represent machine drilling operation always proceed with diameter symbol. This is the drilling operation. There are some different types. There are counter bore, there's a counter sink, and a spot face. And this is how you write the symbols. This is the like a block like that. This is for counter bore, like this one. This one is for counter sink, and this one is for I think the depth symbol, yeah, the depth symbol. So for example here, this is the diameter is 10, while the outer one is the counter bore is the 20, and the depth of that one is 8 millimeter. Okay, and this one is for counter sink. For example, the inner one is 10, and the outer one with the counter sinks is 20 and 90 degrees Celsius. Okay, and over here 90 degrees, sorry. And this one also about the foot space. So you can see that this is the depth 8 and the depth 2. Okay, so here if you see here, the depth is much more deeper compared to this one. Yeah, so you can see the depth of the depth for the spot face of the drilling operation. Okay, and then this is also the dimensioning the blind hole. If you have a blind hole, which is the hole that doesn't pass into all the object here, you need to make sure that there is a depth on here. Yeah, this is gonna be the depth. So at least you know that this is gonna be the depth, then it won't be farther than this one here. Okay, so the depth of the blind hole reflects the depth of the full diameter. Okay, right, if you have something like this, it's not included, so it's only for the full diameter. Okay, and then this one is all how to dimensioning a chamfer. Chamfer means a part that been cut like this. So the angle is actually, you can write it like here. Okay, and this is actually the length, yeah, over the thickness of the chamfer. So chamfers are dimensioned by providing either an angle and the linear distance of the two parallel lines over here, yeah, over here. So for example, this is the external chamfer, or this is the internal chamfer. You can see the dimension or the diameter, and also the angle. Okay, the angle if you continue them like that. Okay, and this one, oops, and the last one, this is the dimensioning slot, that if you have several methods appropriate to dimensioning slot, would be like this one. So there are several methods. First one, you can make this one, there is 2R. So because this is actually the arrow here and tells you about 2R, so would be a radius, and the radius have two radius, so this one and that one. Or if you want, you can add the center point, and then you find the distance between the two center points, or you can you can draw the the middle center point and then see again like that one. Okay, so again, a number of methods in dimensioning slot. All right, everyone. So I think that's all the topics for today. It's actually not much, at least, but the problem I think would be maybe some practice. I think we can stop it here from now. You can watch some video, or you can check again your hands out for the remaining hour. And next week it's gonna be next week is a holiday. Okay, and then I think we will continue for the next 2 weeks about the last one. It's not much. Maybe I can explain from the shared screen again. wait, so this one, so the next week would be the last one. Again, we just have some more about fastener and working drawing, ya, the gambar kerja, and then how to about assembly. Okay, so we can so we can have look later on for this is gonna be in the next 2 weeks, and after that you will have exam from module 1 to module 7. Okay, so do you have any questions before we close the class? Right. Okay. So please open your Edunex and then download it, or maybe you can just watch it here, make some notes, and I don't know if you have some problems from from last year's course. You can try to do that first. Okay. So you should be better prepared from the class. Okay, so with me it's only half a semester, so next 2 weeks gonna be our last class. Okay, all right everyone, so I think that's all for today. So keep safe and healthy, and if you think you ill or something, just let me know, and then let the lecturers know as well. So keep hydrated, and then hopefully now it's week 6, yes, so just 2 weeks before the exam, the mid exam, so I hope you can start preparing it well. Okay everyone, thank you very much, and then I'll see you again next 2 weeks. Bye bye.
Thank you, Miss.
Thank you, Miss.
Thank you, Miss.
Okay, bye bye.
Thank you, Miss.